Hello, welcome to Algebra with Miss Andrea. Today we're getting started on a new unit. It's going to be Unit 8, or rather Module 8. I think they call it Unit 6A, but it's in online. It's Module 8, Unit 6A. It's called Describing Data. So we're getting into statistics in this chapter. And lesson 1, we're going to talk about our keywords and essential questions. So the first thing we need to know about is a box and whisker plot. And that's what is down here. You can see it's aptly named because there is a box that has some whiskers coming out of it, right? So it's a box and whisker plot. And one of the things we're going to get into in a little bit is quartiles. And the box and whisker plot shows us the quartiles. So all of the data that you've collected is shown visually here. So this is the lowest piece of data. This is the highest piece of data. When you take all that data and you divide it right in half, that's quartile 2, the number that's directly in the middle. And then if you take that first half and you divide it in half again, that's going to be quartile 1. But if you take all your data and divide it directly in the middle, that's quartile 3. So let's say you have, I don't know, 600 pieces of information, right? 600 pieces of data. 300 pieces of data are represented there, and 300 pieces of data are represented here. So that's 300 pieces of data, right? Well, you could also break it up and say, okay, well, 300 pieces of data are here. Well, that must mean that there's 150 in this section and 150 in this section as well, right? And then 150 pieces of data here and 150 pieces of data here. So we have 4 sets of 150. That makes 600 pieces. So you can see this is all bunched up. If we have 150 pieces of data in here, they're all kind of jumbled together and really close. Okay, so there's a lot of 4s and 5s, or 4.5, 4.6, 4.2. There's a whole bunch of those because there's 150 pieces of data in here. But those same 150 pieces of data spread between 5 and 7. So those are going to be a little bit more spread out pieces of data. So you're going to have some that say 5.5 and some that say 6.9. Okay, so you're going to have a lot more spread in that data. Okay. It looks like this is spread just as evenly as this one is. So the center 50% of the data is in the box. This is 50% of the data. And then this is the 50% of data that kind of goes outside of the box. All right. So it's a box and whisker plot. All right. Categorical data is data that doesn't have a number. It has a name. Like if we were to take a classroom full of students and ask what's your favorite color, they wouldn't answer 3 or 7. They'd say blue or purple or orange or white or black or turquoise or sienna. Who knows? But they're not going to choose a number. So that would be categorical data. Whereas if we asked what's your age, they would say a number. That is not categorical, right? Oops, I went too far, sorry. Center. All right, measures of center means what kind of things tells us what's in the middle of the data. And there's 2 main measures of center that we're going to get into, which is the median and the mean. And you may already know about those. Hopefully you do, and it will just be a review. Dot plot. Just like the box and whisker plot was a visual representation of our data, our dot plot can be the same thing. So this dot plot shows us how we took a poll of a group of people and said, how many minutes does it take you to eat breakfast? And we had them time themselves, and this was their answers. These many students take less than 1 minute to eat breakfast. These take 1 minute to eat breakfast. These take 2. So each dot, you could say, represents 1,000 students. In that case, there's 2,000 students that take 1 minute. Or your dot could represent 1 student. So you have to identify what each dot represents, but each dot represents that amount. All right, first quartile. So remember we were talking about taking information, cutting it in half, and then in half again. That's how you get to the quartiles. So we're going to take all of this data. I should have written this so that it was all in one line. That would have made it a lot easier for me. Okay, take all of this data and cut it directly in half. Well, how do I know where half is? Well, one method you could do is you could just go like this for start going from the outside in. They're even, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They're even. So in order to figure out what's directly in the middle, you have to find the average of these. 10 plus 12 is 22. Divide that by 2 and you get 11. So 11 is right here in the middle. Now, this is what we would call quartile 2, or the second quartile. That's not what we're studying. We're supposed to be looking for our first quartile. So if this is quartile 2, that tells us, well, first quartile is going to come before that. So let's look at this one. Now let's do this in green. Okay, well, 1, 2, right here. This is quartile 2. So quartile 2 is 6. Okay, we didn't have to do any averaging. It's the one directly in the middle. This is also called the median. The median, the number that's directly in the middle. So we found the median of the data that's on this side in order to find quartile 2. Oops. Let's clear that. Minimum, lower quartile, median, upper quartile, and maximum. This is your 5-number summary. So when you're asked in data for your 5-number summary, you're going to want to give all of that data. Minimum, the lowest number in your data. Lower quartile, that's Q. Well, it's either going to be quartile 1 or quartile 2. The data in that quartile. Median. The median is going to be the number straight down the middle. So lower quartile is going to be quartile 1. The median is quartile 2, which is the information right in the middle. Just like the median is, if you're driving down the road, the cement thing in the middle, sometimes it has trees, sometimes it doesn't. The median is in between the traffic going both directions, right? Well, the median in our math is going to be the number that's directly in the middle of the data. The upper quartile is going to be quartile 3, and then the maximum is the highest number in the data set. So that's all of those pieces of information, the 5-number summary. Histogram. Now, a histogram kind of looks like a bar graph, but it's a little bit different. You see a bar graph here, you're going to have some gaps in between the data. A histogram has no gaps. That's one thing you can look at. A bar graph, you're going to have, you can have names at the bottom of it. Like here, it's names of countries, USA, India, UK, etc. Whereas in a histogram, you have to have number ranges, okay? But it's basically another way to show data visually. So we have number ranges and then all the data pieces. So this has 20 pieces of data that fall between here and here. Whatever it is, it's giving us the information on. It does not tell us what this graph is for, but this graph has 50 pieces of data that fall between the numbers 250 and 300. So there you go. Could be how much money you have in your wallet. Who knows? All right, interquartile range. It's a measure of variation that tells you the distance between the first and the third quartiles of data. Interquartile range. So between the first and third. So we have our data set right here. This is the full data set. Number 1 is the minimum. Number 120 is the maximum value, right? Okay, so if we go back and forth, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's 10 pieces of data. So halfway down will be 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now we have 5 on each side. Since there's no number right here in the middle, how did we find the middle? Well, we added them together and divided by 2. That was 11. Okay, so that's quartile 2. What does that have to do with interquartile range? Well, we need to figure out what quartile 1 and quartile 3 are. Okay, so in order to find quartile 1 and quartile 3, you have to start with the median, or quartile 2. So now that we have quartile 1 and quartile 3, we're going to find the interquartile range. So it's going to be the difference between quartile 3 and quartile 1. So we're going to take quartile 3, which is 15, and subtract quartile 1, which is 6, and our answer is 9. So the interquartile range for this set of data is 9. And that's kind of like, what's all the data in the middle? And if you notice, every time these are put in order from least to greatest. So your data has to be in numerical order in order to do these quartiles and ranges and medians and things. That's important. Mean absolute deviation. Okay, well, we haven't gotten into mean yet, but what a mean is an average, the average number. We remember there's mean, median, and mode. Okay, mode is the number that appears the most. The median is the number in the middle. We've kind of already been talking about that one. Mean is the average. And I like to say it's called mean because it's the one that's the meanest, because you have to do the most work. Because how do you find an average? You add everything up and then you divide by how many things you added up, right? So let's find the mean of all these numbers. So I'm going to add 2 plus 3 plus 6 plus 7 plus 10 plus 12, etc., etc., etc. All right. 2 plus 3 plus 6 plus 7 plus 10 plus 12 plus 14 plus 15 plus 22 plus 120. I got 211 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data is going to be 21.1. And I got that in my calculator. So this is what we're going to call the mean. So now the mean absolute deviation says, okay, well, mean means we're going to find the average of something. What are we going to find the average of? The absolute deviation. So absolutes means absolute value. So that means none of our answers are going to be negative. Deviation is the difference from the mean. All right, so if 21.1 is our mean, we're going to take each pieces of these data and subtract it from the mean. So I'm going to do 21.1 and subtract 2. Let me change my color for this. 21.1 subtract 2, and I get 19.1. Subtract 3, I'm going to get 18.1. Okay, 21.1 subtract 6, I get 15.1. 21.1 subtract 7, I get 14.1. 21.1 subtract 10, I get 11.1. 21.1 subtract 12, I get 9.1. 21.1 subtract 14 is 7.1. 6.1. Now 21.1 subtract 22, I get negative 0.9. But remember, absolute deviation, meaning the absolute value, which means the positive of whatever it is. So we're not going to have a negative 0.09. It's just going to be 0.09. So then 21.1 minus 120 is 98.9. Okay. So now that I have all of those numbers, we just found the absolute deviation, right? The difference from the mean and the absolute value of that. Now we need to put the word mean on it, which means we have to add them all up again. All right. So 19.1 plus 18.1 plus 15.1 plus 14.1 plus 11.1 plus 9.1 plus 7.1 plus 6.1 plus 0.9 plus 98.9 equals 199.6 divided by 10. And I got 19.96, rounding up gives me 20. So that's mean absolute deviation. Mean, we just talked about that. What is mean? You're going to add stuff up and then divide by how many there are. One thing you need to know is that the mean is also known as the X bar, which means it's X with a bar over it. So our mean on the last one was 21.1. So you have the X bar tells us mean or average. Okay. Most of the time in statistics, you'll see Greek letters. Like for standard deviation, you use a sigma. For what do you use for pi? The average is the pi. So you're going to be seeing a lot more Greek letters when you get into statistics like this, but for mean, it's an X bar. Number of peaks. Okay, so when you take all your data and you plug it all in, say those dots, the dot graph that you had, right? Well, we had all these different dots that were doing this. Well, if you took all that data and you plugged it in and drew like a chart over it, right? That would be another way, instead of the dots, to have a visual representation of the data. Okay, now the number of peaks that it has is another identifying factor. So these are called distributions here when you see it in a hill-like format, right? So these distributions, this one has 1, 2 distinct peaks. Okay, so this would be a bimodal distribution. Now, a unimodal distribution will have 1 peak. Unimodal is also called a normal curve or a bell curve or a Gaussian distribution. Now, this is the one, the normal curve. It's called normal for a reason, because like 99.9% of all the data you're going to ever work with in statistics will fall into a normal curve, a bell curve, or a Gaussian distribution, unimodal data. So this is the one you're going to deal with 99.9% of the time is a single peak. But number of peaks is another way to identify your visual data that you have. All right, so outlier. Outliers mean, especially like the data we were looking at before, it had all these small numbers and then it had the number 120 on the end. But none of the other ones got above like 8, I think it was. The number 120 was an outlier because it wasn't really close to the other data. So if you have all this data that's grouped together and then this one that's like really, really, really far away, it's kind of outside the norms, that's called an outlier. Quantitative variables are variables that represent something that can be measured. So it has here as an example, a population of a city. So the population is a quantitative variable, scores of a test, height, weight, temperature, etc. So these things can be measurable. The alternative form is qualitative, which cannot be measured, right? So quantitative means it can be measured, something that can be measured. Median, we've been already talking about that. It's exactly what's right down the middle. And if you don't have a number in the middle of your data set, when it's in order from least to greatest, then you take the average of the 2 pieces of data that are closest to it. All right, range is going to be the difference between the smallest piece of data, the minimum, and the largest piece of data, the maximum. If you take the largest piece of data and subtract the smallest piece of data, that's your range. Very similar to when we had the interquartile range and we found quartile 3 and quartile 2, and we subtracted quartile 2 from quartile 3 to find the interquartile range. Just the regular range is the biggest number minus the smallest number. All right, second quartile is the median value. So the number straight down the middle. When you have it ordered from least to greatest, the number right down in the middle. And if you don't have one, you average the 2. So second quartile is the exact same thing as the median. Just 2 different words to describe the same thing. Usually you won't see second quartile. Usually you'll see median. Shape. The shape of distribution describes its symmetry, its number of peaks, its direction of skew, its uniformity. So on a normal curve, it's supposed to be, I did not draw it well, but it's supposed to be symmetrical on both sides. Okay, that's one thing you will see. A skew, if something is askew, it could look like this. So it's going to be, all the data kind of fits. I don't know if I'm drawing this well. So you're not growing very much at all. And then all of a sudden, look, some growth and then a decline. So this is a skewed graph, meaning it's kind of all on one side. It's all kind of, all your data is going to be lumped on one side. Okay. Direction of the skew is to the right. Okay. So, uniformity, is it if it's uniform, it's going to be just like a straight line straight across. There's not going to be any peaks. You're going to have some uniform data, meaning it's all the same. Symmetry. A symmetric distribution can be divided in the center, so each half is a mirror image of each other. I think we kind of already talked about that. Skew, we already talked about. Spread, how far spread out it is, the variability of the data. So if it's just kind of clustered around one little thing, or if it's all spread out from that center number. So like it has to do a lot with range. How wide is the data from the beginning to the end? So the further the observations fall from the center, the greater the spread or variability of the set. So the range, the interquartile range, the mean absolute deviation, standard deviation, all of those measure spread. Different ways to measure spread, and each type of measuring will give us different insights on the data. So sometimes it's better to use one way of measuring spread than another. Third quartile, again, you take all your data, you have it arranged from lowest to greatest, you split it in half. Once you've split it in half, the third quartile is going to be in this upper set. You're going to split that in half again. If there's not halves, you have to take and average the two numbers to get that exact number in the half. Uniformity, again, that's going to be a graph that just doesn't really have any definitive peaks and kind of is almost a straight line. Or it could be a straight line. So essential questions. What kind of things are we going to cover in this unit? How do I summarize, represent, and interpret data in a single count or measurement variable? When making decisions or comparisons, what factors are important for me to consider in determining which statistics to compare? Which graphical representation should I do? Remember, we talked about histograms, dot plots, box and whisker plots, all kinds of stuff, and bell curves. Which one should I use to represent my data? How can I use those visual representations and the measures of center and the spread to compare data sets? Which one should I do? Which measure is going to help me compare it better? Why is technology valuable when making statistical models? How can I apply what I've learned about statistics to summarize and analyze real data? Right now, I'm going to say people who are statisticians make buku money. If you go into statistics and you love it and you do well, you can make some great money. We use statistics to Facebook, any of the social media. Uses statistics to create formulas to show you all the stuff that comes up in your newsfeed. If you're on TikTok, all the suggested for you comes up based on what you've already looked at. So they've created statistical models to show you things that you might like. And these people are the drivers of the money in our society. So if you do statistics, if you do it well, you can make some great money. All right, well, that's it. I'm excited about this upcoming unit and the next lesson, but we are done for today. So I'll see you on the next one.